So what is a transformer? The voltage of an alternating current can be changed using a device called transformer. So by using transformers, we can change voltage levels from one value to another value. Simultaneously, current values also changes. If you increase the voltage levels, the transformer is called step-up transformer. If you decrease the voltage levels, the transformer is transformer. Suppose if you do 230 volts for a transformer, so that voltage is increased to 400 volts. The transformer is called step-up transformer from 230 volts to 400 volts. So the transformer is called step-up transformer. So if here we give 230 volts, 230 volts, then we get 400 volts output, 400 volts output voltage, 400 volts. Then the transformer is called step-up transformer. So that depends upon number of turns. That depends upon number. So basically, transformer having two coils. Two coils. The coils are made with copper winding. So this is the primary coil. This is the primary coil. This is the primary coil. So this is the secondary coil. So if number of turns on secondary is more than the primary, number of turns, that is the NP. NP is the primary turns. NS is the secondary turns. So if NP is greater than NS, NP is greater than NS, so the transformer is called step-up transformer. See, 230 volts is converted into 400 volts. So the transformer is called step-up transformer. So similarly, if the number of turns in primary is more as compared to secondary, the transformer is called step-down transformer. That means here the voltage is converted, 230 volts is converted into, so 230 volts is converted into 115 volts. Then the transformer is called step-down transformer. Depending upon number of turns in primary or secondary, the transformer voltage levels changes. Simultaneously, current levels also changes. Suppose here the primary current is 10 amperes in 230 volts case. In 230 volts case, primary current equal 10 amperes. So the proportionately the current values also changes. So 230 becomes 440. So 10 amperes becomes almost half. That is 4.5 amperes like that. 5.5 amperes like that. So current values also changes. Voltage values changes. Simultaneously current values changes. So power always constant. In the electro transformer, we are not able to increase the power levels. Power is always constant. Somewhat decreases to meet the losses. Somewhat power output decreases as compared to input power. So to meet the losses in the transformer. Transformer contains two coils are wound around the soft iron core. Iron core purpose is to provide the mechanical support and to provide the path for magnetic flux. Path for magnetic flux. So the purpose of the iron core is it provides mechanical support to the windings. The second purpose is it provides path for magnetic flux produced by the primary coil. So the alternating current in the primary coil produces the alternating magnetic field. So transformer is an AC device. It operates only on AC. Because this is a static device, there is no rotating parts. So if you want to transfer energy from one form to another form, we need motion or alternating flux. We need motion or alternating flux. We know that in generators we have rotating part, that is we give mechanical input to the rotor. In case of DC generators, we give mechanical power to the rotor. So rotating part cuts the stationary magnetic field, EMF will be induced in the armature, and that is the principle of DC generator. Similarly, in case of transformers, transformer is a static device, there is no rotating parts, so that's why we give alternating current. Alternating current means that automatically produces alternating flux. Alternating voltage produces alternating current. Alternating current produces alternating flux. So the alternating flux produced by the primary coil, leaves the secondary coil. Suppose we give alternating supply voltage to the primary. So this is the alternating supply. If we give alternating supply to the primary voltage, alternating voltage, this carries alternating current. So this current produces flux because flux is proportional to current. So that means the flux is the alternating flux. The alternating flux produced by the primary leaves the same coil. So this is the alternating flux produced by the primary coil. EMF will be induced in the primary coil. That is called self-induced EMF. The flux produced by the primary coil leaves the same coil. EMF will be induced in the primary coil. That is called self-induced EMF. Self. So same flux, the flux produced by the primary links with the secondary by passing through lower reluctance path. So this is the flux. The flux produced by the primary passes through iron core and links the secondary coil. EMF will be induced in the secondary coil. That is E2. That is called mutually induced EMF. So self-induced EMF E1, mutually induced EMF E2. When load is connected on secondary side, electrical load is connected on secondary side. This is the secondary load, electrical load. Secondary current will exist. So that is I. Secondary current. So primary current I1, primary voltage V1, secondary induced EMF V2, secondary voltage V2. So induced EMF C1, V2, V2, I2, V1, I1, V1, I1. So in this manner, power is transferred from primary to secondary through magnetic medium. In this manner, power is transferred from primary to secondary through magnetic medium. So there is no electrical connection between the primary and secondary. There is no electrical connection. There exists an isolation between the primary and the secondary. So the power is transferred only through magnetic medium. There is a coupling between the primary and secondary through magnetic flux only. So here energy is converted from electrical to magnetical and magnetical to electrical. So in case of generator, mechanical energy is converted into electrical energy. In case of DC motor, electrical energy is converted into mechanical energy. So here in case of generator, medium is flux. Here also same. Electrical energy is converted into magnetic energy and magnetic energy is converted into electrical energy. Same. So finally electrical input, electrical output. Only medium is a magnetic flux. So in machines, electrical to mechanical, mechanical to electrical, medium is a flux. In that case also medium flux, here also medium flux. So only energy transformation is electrical to electrical in transformer. So it operates only on AC. So this magnetic field induces an alternating current in the secondary. So this is the principle of Faraday's laws. So transformer also operates on Faraday's laws of electromagnetic coupling. So here see the difference between the step-up transformer and step-down transformer. So in step-up transformer, here a number of turns in secondary N2, here N1, primary turns N1. Sorry, N1 is less than N2. Or N2 is greater than N1. Here N1 is greater than N2. N1 is greater than N2. N1 is less than N2. Step up voltage step ups. For example, this is 200 volts. Take 200 volts. So these are 400 volts, depending upon number of turns. Maybe 400 volts or 600 volts, depending upon number of turns. So it means voltage increases. In this case, so 400 volts input to 400 volts input to output to 200 volts. Step down. Output to 200 volts. So this is step down transformer. So as per current, suppose the primary carries 10 amperes. So proportionately current value decreases. So voltage increases, proportionately current value decreases. So secondary current value 5 amperes. So voltage becomes double, 200 to 400. Current 10 amperes to 5 amperes. So here voltage increases, current value decreases from 10 amperes to 5 amperes. Similarly in this case, so this carries 5 amperes of current. This is all our examples. This carries 5 amperes. This carries 10 amperes of current. Secondary carries 10 amperes of current. So 10 amperes of current. In that manner, we use transformers. So main purpose of the transformer is to change the voltage levels only, not power levels. With the help of transformer, we are not able to change the power levels. We change the voltage and current levels only. So this is the working principle of the transformer. Suppose an alternating voltage is given to the primary winding. An alternating voltage is given because transformer is an AC device, so it operates only on AC, alternating current. Alternating voltage is applied, alternating current will flow. So alternating current will flow. So this alternating current produces flux, right? The flux produced by the primary coil links the same coil. Flux produced by the primary coil links the same coil. EMF will be induced in the primary. So the flux produced by the same coil links the secondary coil. EMF will be induced in the secondary. So E1 and E2, self-induced EMF, mutually induced. E1 is called self-induced EMF, E2 is called mutually induced. Here the core, this is the core. Core means this is the core. Core provides mechanical support to the winding and it provides low reluctance path for magnetic flux. And the main two purposes of the core is it provides mechanical support and provides low reluctance path for magnetic flux. So what are the types of the transformer? So depending upon the number of phases, so according to number of phases, single phase transformers, three phase transformers. According to construction, core type, shell type, and buried type. Construction depending upon the construction. According to the operation and application where we use it, that is the power transformers and distribution transformers. In power transformers, step up and step down. In all transformers, step up and step down existing. So depending upon construction, depending upon number of areas, depending upon the applications, power transformers and the distribution. Why do we need transformers? So what is the main purpose of the transformer? Why we need transformers? Because of the transformers, only AC systems are more popular than DC systems. Only because of the transformers. So with the help of transformers, we increase the voltage to the generator output to transmit the power at low currents. With the help of the transformer, we increase the voltage levels and therefore current levels decrease. Therefore, current levels decrease means power is transmitted to long distances. Because current levels decrease means I square R losses decreases. I value decreases, I square R value decreases. I square R value decreases means losses value decreases. Losses decrease means transmission efficiency increases. So efficiency increases means cost reduction decreases or unit cost decreases. So with the help of transformer, we adjust the voltage to a suitable visible level at the receiving end of the transmission line. Another one is transformers provides electrical isolation between the two systems. Transformers provides electrical isolation because there is no electrical connection between the primary and the secondary in transformers. Because suppose this is the primary, so this is the secondary. No direct electrical connection between the primary and secondary in transformer. No electrical connection. Only magnetic coupling is there. Magnetic coupling, no electrical connection. So that's why isolation is provided with the help of the transformer. Impedance matching and transformers act as a filters for DC. So this impedance matching is used in electronic circuits. Transformer act as a filter for DC components. Why do we need transformers in antenna system? Means high transmission voltage required is achieved by using transformers. Convert AC voltage of any value to any desired value. Use suitable turns ratios of transformer windings. That means by changing the number of turns on primary and secondary, we can change the voltage levels. This transformer only applicable for AC circuits, cannot be used for DC circuits. So this is a very important point. Transformer is an AC device, operates only on AC, not on DC. Not on DC, only AC. So when only because of transformers, power can be transmitted to long distances. By reducing the current, by reducing the losses, by increasing the efficiency, power can be transmitted through long distances. So at the receiving end, with the help of the transformers, voltage values are reduced to a safe level only because of transformers. Display purpose is it converts AC power at one voltage level to AC power of the same frequency at another voltage level. So we have an introduction of the transformer. One greatest advantage of alternating current over DC current is alternating currents can be easily transferable from one lowest to voltage to highest value only because of transformer. So low value to high value to low value. So alternating voltage can be raised or lowered as per requirement in different stages of electrical network as generation, transmission, distribution, and utilization. So this is possible with only transformers. Suppose power is generated at generating stations with the help of generator. The generated voltage is stepped up by using a transformer and transmitted, power is transmitted with the step up voltage step up with the help of the transformer T1. So this is the transmission line, PR line. So transmission line, generator, transformer, transmission line, another transformer, another transformer. So with the help of another transformer, we decrease the voltage to usable value or safe value, and then we use the voltage. So this is the distribution system, distribution transformer or step down transformer, transmission line, so step up transformer, generator. So generated voltage is step up by using a transformer and transmitted at receiving end we reduce the voltage with the help of another transformer. This means this is a step up transformer, so this is a step down transformer and used at utilization centers. So according to Faraday's laws, EMF induced are classified into two types. EMF induced value of EMF is classified into two types: dynamically induced EMF and statically induced. So dynamically induced EMF means generators. Generators generate power on principle of dynamically induced EMF. Statically induced EMF means a transformer. Transformer operates on statically induced EMF. Statically means stationary. Dynamic means motion. So in generator, mobile parts is there. In transformer, there is no mobile parts. All are stationary parts. So self-induced EMF, statically induced EMF further classified into two types: self and mutually induced. Self-induced EMF and mutually induced EMF. So dynamically induced EMF made up of the generator. So this is Faraday's, depending upon Faraday's laws, we classify the induced EMFs basically two types: statically, dynamically. Statically means stationary. Dynamically means motion. So the generator operates on dynamically induced EMF principle. Transformer operates on statically induced EMF principle. So from transformer we have two coils in single phase transformer. So this is the two coils in the transformer. So here the EMF induced is called E1 is called self-induced EMF. Here the EMF induced E2 is called dynamically induced EMF. E2 self-induced EMF. So this is the self-induced EMF. Dynamically induced EMF. So this is the dynamically induced EMF. Dynamically induced EMF. E1 is self-induced EMF. E2 is mutually induced EMF. So transformer operates on statically induced EMF, generates operates on dynamically induced EMF. So generator, transformer, transformer statically, generators to dynamic induced. Same. So statically induced EMF. Conductors remains stationary and flux linked with it changes. Alternating flux. Alternating flux is existing only in alternating voltages, alternating currents or alternating voltages. So that means statically induced EMF exists in transformers. Because in transformers all are stationary parts. Here we have self-induced EMF and mutual induced. So here the EMF induced is called self-induced EMF. Here the EMF induced is called mutual induced. Dynamically induced EMF. Field is stationary and conductor cuts across it. Either the coil or magnets are moving. Anyone is moving in generators. Armature coils or field. Anyone is moving. We have two main coils in generators, field coils and armature coils. But in DC generators, armature is rotating, field is stationary. But in AC generators, armature is moving or field is stationary, or field is moving, armature is stationary. When a conductor is placed in a varying magnetic field, an EMF gets induced across the conductor called induced EMF. And if the conductor is closed circuit, then the induced current flows through the Faraday's laws. You already know the Faraday's laws. Magnetic field can be varied by various methods. By moving magnet, moving coil, rotating the coil will to the magnetic field. In simple way, when the magnetic flux links with the circuit changes, EMF will be induced. So this is the principle of the transformer. When the magnetic flux links with the circuit changes, EMF will be induced. So this is the dynamically induced EMF. Faraday's laws for dynamically induced EMF. Here the conductor is rotating, magnetic field system is stationary, conductor is rotating. So this is the conductor. The conductor is rotating, field system is stationary. So this is the principle of dynamically induced EMF, generator principle. Armature conductors are rotating, so motion, dynamically induced. Field is stationary. Field is stationary. So this is because of dynamically induced EMF principle. Current carrying conductor produces magnetic field around the conductor. Magnetic field due to a current carrying conductor. Because every current carrying conductor produces magnetic field. Every current carrying conductor produces a magnetic field. A magnetic compass is placed near the conductor carrying current. The needle is deflected. This shows that conductor carrying current has a magnetic field around the conductor. Very, very important point. Every current carrying conductor produces magnetic field around the conductor. The direction of the current in the form of north to south, the deflection of the magnetic field is towards the east. So this is the current carrying conductor, carries current in this direction. This is the magnetic lines of force direction. See, wire. So this is the magnetic field direction. So deflection of the current, this is the deflection of the current in this way. So this is also a principle of the transformer expression. When AC supply is given to the primary coil, this is the primary coil. You have primary coil, copper coil. So alternating supply voltage. So alternating current will flow. So primary V1, primary voltage, primary current I1. So flux is existing I1. So the flux produced by primary coil is the same coil. EMF will be induced by E1. So that is called self-induced EMF. E1 is called self. So same EMF induced in the second wheel because of primary coil. E2. This is called mutually induced EMF. Mutual induced EMF, that is in E2. So that's why transformer operates on mutual induction principle. So that's why we call transformer operates on mutual induction principle. So that is Faraday's laws of electromagnetic induction. Faraday's laws of electromagnetic induction. See, in this transformer, we have same number of turns, NP and NS. See, primary having NP, secondary having NS. If NP equal to NS, NP equal to NS, the transformer is called isolation transformer. So that means voltage and current levels are not changed. The purpose of the transformer is to isolate one circuit to another circuit. Same number of turns, NP and NS. NP equal to NS, the transformer is called isolation transformers. If NP is greater than NS, so that means primarily having more number of turns, that is called step-down transformer. Primary having less number of turns, that is called step-up transformer. So see here, primary having more number of turns, secondary having less number of turns. So this is a step-down transformer. N secondary having less number of turns, that is called step-down transformers. NS having less than N, that is called step-down transformer. More number of turns on primary, more number of turns on primary, more number of turns, less number of turns on secondary. There is nothing in transformers. Transformer having only two coils, two electrical coils. There is nothing existing in transformer. Only two coils, primary coil and secondary coil. So this is a single phase transformer. If it is a three-phase transformer, 2 into 3, 6 coils, primary 3 coils and secondary 3 coils. So this is a step-up transformer. Lower number of turns on secondary, lower number of turns on secondary, less number of turns on primary. So when we give supply, that is called primary. When we connect load, that is called secondary. Primary, secondary. Primary winding, secondary winding. Input to output. So here and secondary having low number of turns. Secondary having low number of turns. NS. Secondary and primary. NS having low number of turns, that is called step-up transformer. Step-up voltage. Simultaneously current decrease. As far as voltage, it is step up. As far as current, it is step up. So this is the single line diagram of the power system. Power is generated at generators. The generated voltage is increased with the help of the transformer. So there is a transformer, step up transformer. Transformer. So this is step down transformer. Step down transformer. The generated voltage is step up to transmission line to the transmission line. So this is the load centers. There is a motor supplemented. So the main purpose of the transformer is to increase the voltage levels, transmission line levels, and decrease visible values with the help of the transformer. Only because of transformers, power is transmitted through long distances. So this is another circuit. Generating station. The generating station. So there is a transformer for increasing the voltage transmitted. So this is another transformer. This is the step. First one is step down, step up. Second one step down. Okay. So for industrial purpose, we give more voltages. That is 33 kV, 11 kV, or 66 kV. For distribution of commercial purpose, so for small purpose, house, commercial, residential customers, lower voltages. So this is a distribution system. So this is another transformer. So these are all distribution systems, sub-transmission, sub-distribution systems. Okay, in that manner, power is transmitted and utilized. So this is total electrical system. Single line diagram of the electrical system. Generator. Generated voltage is increased to transmission voltage. It is 400 volts, 500 volts, 700 volts like that. 700 kV, 200 kV like that. Power is transmitted to long distances, and step down. Sub transmission means 60 kilometers, 70 kilometers like that, and utilization at the distribution system. Same, single landing on the system. Power plant. So this is the power plant. Step transformer. With the help of step transformer, voltage increases transmitted long distances. Power substation. So step down transformer. Initially step up transformer. Here we have step down transformer and utilization. The only purpose of the transformer is to increase the voltage levels.
Transformer is an electromagnetic static device in which input is in form of electrical energy and output is also in electrical form. Also, the input and output both are in alternating form. Primarily, transformers are used to change level of voltage and current. For example, in case of step down transformer, the input high voltage is transformed to a low voltage, whereas the magnitude of current is increases because input and output power has to be remain same. Working of a transformer can be understood by taking a simple example of a small piece of wire carrying current when it is connected to a battery. As a result, a magnetic flux gets set up around the conductor. If another piece of wire comes in the vicinity of this flux, an electromotive force is get induced in the conductor, which we can see here form deflection in needle of a galvanometer. But after some time, deflection becomes zero. Because both conductors are stationary means there is no relative movement between them. This is known as dynamically induced EMF. Further, we can also experience that EMF is again induced in the second conductor when we remove battery. This is because of reduction in flux density around the first conductor, and the second conductor try to oppose this change in flux as per Faraday's law of electromagnetic induction. The magnitude of EMF induced is given by E2 is directly proportional to d phi by dt. This electromagnetic coupling between the two conductors can be improved by two methods. Number 1, by using coil on both sides instead of using single wire. This results in increase of flux. Number 2, by using a magnetic core between the coils, which gives low reluctance path to the flux and improve magnetic coupling between the coils. As you can see here, in this case, coil of left side, or we can call it primary coil, has lesser number of turns than the coil on right side, or we can call it secondary coil. And the transformer is called as step up transformer. In this case, voltage which induced on secondary coil V out is higher than the voltage which is applied Vn on the primary coil, whereas the current get reduced as the power has to remain constant. Similarly, when primary coil has more number of turns than the number of turn in secondary coil, the transformer is called as a step down transformer, and the voltage induced on the secondary side V out is less than the applied voltage Vn on primary side. The core which is practically used in a transformer is actually not a solid core. It is made up of number of thin sheets of metal called laminations. This type of construction is used to reduce eddy current loss, which occurs inside the core when it carries changing or alternating plugs. As core is used to provide a low reluctance path to the magnetic flux, but the core is subjected to circulating electric currents. These circulating currents, called eddy currents, produced heating and energy losses within the core, results in decreasing the transformer's efficiency. This circulating current is produced mainly due to EMF induced in the iron core, as it is constantly being subjected to the changing magnetic field set up by the external sinusoidal supply voltage Vn. To reduce these unwanted power losses, thin steel laminations is used to construct the transformer core. Laminations are made up of highly permeable material, that is silicon steel. These laminations are assembled together to build a solid core. The resistivity of the steel sheet itself is high, reducing the eddy current losses while making the laminations very thin. The thickness of these laminations is vary between 0.25 mm to 0.5 mm, and as steel is conductor, laminations are electrically insulated from each other by a very thin coating of insulating varnish or by the use of an oxide layer on the surface. The problem with the construction, which is so far discussed here, is that the two windings are well separated from each other, and there is considerable reduction of magnetic coupling and hence the efficiency of the transformer. This disadvantage can be overcome by using constructing core like this, in which the two windings are bring close to each other, thereby improve magnetic coupling between them. Hope now you have a little bit idea about principle of working of electrical transformer and about its construction. We will discuss it in more details and other topics related to electrical transformer in our upcoming videos.
Series on electrical engineering, so do check out the other videos if you've not done so already. Links are in the video description below. There are two types of electricity, AC and DC, but transformers can only work using AC or alternating current. Now, if you don't know the difference between these two, then please first of all watch the video on electricity basics first. Again, you can find links to these videos and other useful videos in the video description below. When we connect an AC generator to a closed loop of cable, a current will be able to flow through this cable and the direction of the current will alternate backwards and forwards with the rotation of the generator. The alternation means that the current reaches its maximum and minimum point during the cycle, which gives it its sine wave pattern when connected to an oscilloscope. Now you can think of this as the tide of the sea as it changes direction and reaches its maximum and minimum point. As the current flows through the cable, it will emit a magnetic field. If we pass DC current through the cable, the magnetic field will remain constant. But if we pass AC current through the cable, then the magnetic field will increase and decrease in strength and changes polarity as the current changes direction. If we place multiple cables together and pass current through them, then the magnetic fields will combine to create a stronger magnetic field. If we then wrap the cable into a coil, the magnetic field will become even stronger. If we then place a second coil in close proximity to the first coil and then we pass AC alternating current through the first coil, then the magnetic field it creates will induce a current into the second coil, and this magnetic force will push and pull on the free electrons, forcing them to move. The key component here is that the magnetic field is changing polarity as well as intensity. This change in intensity and direction of the magnetic field constantly disturbs the free electrons in the secondary coil, and this forces them to move. This movement is known as electromotive force, or EMF. Electromotive force does not occur when we pass DC current through the primary coil, and that's because the magnetic field is constant, so the electrons are not being forced to move. The only time it will cause EMF is very briefly when the primary circuit is opened and closed, or when the voltage is increased or decreased, and that's because these actions result in a change to the magnetic field. Therefore, we use alternating current as this change occurs constantly. Now the problem with this setup is that a lot of the magnetic field from the primary side is being wasted because it's not in range of the secondary coil. So to fix this, engineers place a core of ferromagnetic material such as iron in a loop between the primary and secondary coils. Now this loop guides the magnetic field along a path to the secondary coil so that they will share the magnetic field, and this makes the transformer much more efficient. Now, the use of an iron core is not a perfect solution. Some energy will be lost through something known as eddy currents, where the current swirls around the core and this heats up the transformer. And this means that the energy is lost as heat. To reduce this, engineers use laminated sheets of iron to form the core, and this greatly reduces the eddy currents. Transformers are manufactured to be step-up or step-down transformers, and these are used to increase or decrease the voltage simply by using a different number of turns within the coil on the secondary side. In a step-up transformer, the voltage is increased in the secondary coil, and this will mean that the current will decrease. But don't worry too much right now about why that occurs. We'll look at this in a later electrical engineering video. To increase the voltage in a step-up transformer, we just need to add more turns to the coil on the secondary side than the primary side. In a step-down transformer, the voltage is decreased in the secondary coil, which means that the current increases. To do this, we just use less turns in the coil on the secondary side compared to the primary side. For example, a power station needs to transport the electricity it has generated over to a city some distance away. The power station will use a step-up transformer to increase the voltage and reduce the current, as this will reduce the losses through the long transmission cables. Then, once it reaches the city, this will need to be reduced to make it safe and usable by buildings and homes, so there will need to be a step-down transformer. The transformers for commercial buildings and power stations are usually in a three-phase configuration. You'll see these placed around your cities and towns, and they'll look something like this. These three-phase transformers can be made from either three separate transformers that are wired together, or they can be built into one large unit with a shared iron core. In this setup, the coils will typically sit concentrically within one another, with the higher voltage coil on the outside and the lower voltage coil sitting on the inside. Now these coils are insulated from one another so that only the magnetic field will pass between the two coils. To connect the two sides, there are many different configurations, but one of the most commonly used is to connect the coils in a configuration known as delta Y, sometimes referred to as delta star. This refers to the primary side being wired in a delta configuration and the secondary side being wired in a Y configuration. The center point of the Y side, where all three connectors meet, is often grounded, which allows for a neutral line to also be connected. We'll cover transformer connections and calculations in other more advanced videos, as this can get quite complex. So for now, simply focus on how they work to build your base knowledge. Okay, that's it for this video. Thank you.
Okay, tomorrow I will explain what are the types of transformer, that is about construction of the transformers.